So just to recap what we have studied from our previous discussion, just to summarize our previous discussion. So last meeting, we have studied all about the different methods of designing pre-stress concrete elements. So we have learned how to find the total stress acting on a concrete element at any section along the span of the concrete itself. So the first method that we have studied is about the basic concept method, wherein the stresses on concrete are found by the superposition of the stresses due to the actual pre-stress force, due to the moment resulting from the eccentricity of the pre-stress force, and the moment due to the external gravity load. So in equation form, this is the formula for finding the total stress acting on the extreme tough fiber or the extreme pre-compressed fiber and the extreme pre-tension fiber of the simply supported concrete element that we have studied from our previous meeting. Although you can also apply this even if it is not a simply supported beam, as long as you will correctly identify which are the fibers that are pre-compressed and pre-tension, meaning as the concrete element supports itself, the fiber experiences uh, compression or tension as the concrete element supports itself. So that is how you can say that the fiber is pre-compressed or pre-tension. So you just have to apply this accordingly. So even if the beam is not simply supported, so as you can see on the formula itself, the total stress are just the sum of the axial stress, flexural stress due to the eccentricity of the pre-stress force, and the flexural stress due to the moment due to the external gravity load applied to the beam itself. So that's the first method that we have studied from our previous discussion. Second method is almost related to the first method, which is the C-line method, wherein the stresses on concrete are found by the superposition of the stresses due to the actual compressive force from concrete and the moment resulting from its eccentricity. So in equation form, the formula for C-line method is this, wherein we utilize the uh, total compressive force acting on the concrete element itself. So you can see here, uh, the formula is just the sum of the actual compressive stress coming from the total compressive force acting on the concrete and the moment due to its eccentricity. And you have to take note that the force P, which is the prestressing force, is just equal to the total compressive force acting on the concrete itself. And the last method that we have studied is what we call the load balancing method, wherein the stresses on concrete are found by the superposition of the stresses due to the actual pre-stress force and the moment resulting from the unbalanced gravity load or unbalanced external gravity load. So in equation form, it is equal to this formula, which is just the sum of the actual pre-stress force, the uh, actual stress and the flexural stress due to the unbalanced external gravity load. So in load balancing method, we just have a goal of finding the load that will just balance the eccentric moment due to the eccentricity of the pre-stress force acting on the pre-stress reinforcement. So the moment that will be induced by the additional unbalanced load that will be applied to the concrete element uh, is the moment that we will substitute here on the formula. So another goal on load balancing method is again to produce a uniform stress all throughout the length of the member or the concrete element. So we want to have a uniform stress equal to the actual stress only at any section on the concrete element. Any in a section on the length of the concrete element. But in the case wherein additional unbalanced load will be applied to the concrete element itself, the flexural stresses due to the unbalanced bending moment induced by that unbalanced load will be uh, considered on finding the total stress acting on the concrete section of the concrete element. Other things that we have studied from our previous discussion are the stages of prestressing. So we have studied, initially we have studied three stages of prestressing. So we have the three major stages of prestressing. First one is the initial prestressing at transfer, wherein the force resulting from jacking the prestressing reinforcement is transferred to the fully supported concrete. So in this stage, the concrete element itself is still fully supported by the precasting bed, and then the prestressing force acting on the prestressing reinforcement is transferred to the concrete element itself. So that is what happens at initial prestressing at transfer. And then after that, the next stage will occur, which is the initial prestressing at transfer with self-weight, wherein the concrete experiences already a what we call camber, which is the bending of the concrete element itself, bending upward of the concrete that experiences the prestressing force that is transferred by the prestressing reinforcement. So because of that camber, uh, the concrete element itself is forced to support its own weight. So since the concrete element itself now supports its own weight, therefore it already experiences bending moments uh, due to its own weight. So that is what happens on this particular stage. So the last stage of pre-stressing that we have studied from our previous discussion is the service load condition, wherein the superimposed dead and live load are carried by the concrete element itself, but the tendons already experience pre-stressing losses. So you can expect at this particular stage of pre-stressing, the pre-stressing force acting on the pre-stressing reinforcement uh, uh, has now a reduced magnitude because of the occurrence of what we call pre-stressing losses, which are the main topic of our discussion for this meeting. So that is the summary of our previous discussion.